Hello everyone. Today I will show you the project we did recently. First, let me introduce my group members. They are Xu Liu, Xinghao Wang, which is me, Sen Zhang, and Wu Zhang. Next, I will briefly talk about the project. This project is to build a web-based database query system. The platforms we use are AWS EC2 with Linux 2 instance in it, RDS with MariaDB instance, Redshift, and S3 bucket. We use Python and Boto3 for data loading and processing, the Django and Bootstrap for web development, MariaDB, PyODBC for database connection, Pandas for data normalization, and last but not least, the Django Tables 2 for query result rendering. Next, let me see the real picture of our AWS account. Here in Services, you can find EC2, and we can see that there is a running instance here. And I want to illustrate one point, which is the security groups. We need to open many ports for the connection. For example, we have Redshift port, we have MariaDB port, we have SSH connection port, and the Django application port. Okay. Next, let me see the RDS. As we can see here, there is DB instances. There is a DB instance, which is MariaDB instance. And same, Redshift, we have two clusters, and we only use one of them. And so is the S3 bucket, because it's simple. Let me continue. To simplify the operation of EC2 instance, I created a graphic user interface of it. That's a really big convenience because with it we can interact with our server more easily. Next, I will show you the data normalization of the second database, which is ABC Retail. So originally we have only one file named ABC Retail .txt. But the problem is there is a lot of redundant data in the file, and we want to remove the redundancy. We can do that by divide it into several files. Each file is entity or table. The first step we need to do is to design an ERD for the data. Here, we have 6 entities, which is stuff, city, customer, order, product, and order product. In each entity, I add a ID in it to simplify the representation of each record. For example, in staff, we have staff ID, which is unique. We have first name, last name, title, and the combination of first name and last name is unique. City has city ID, which is unique, and city name, which is also unique, and country. Customer has customer ID, which is unique, a contact name, company, and phone. All of the three attributes, I think, are all unique. Older has older ID, older date, older shipped date, which is optional according to the data we have, and older freight. Product has product ID and product name. Both of them are unique. Older product is a little special because it is a weak entity and it references both older and product. One more thing about it is it has a derived attribute amount. Amount is the multiplication of unit price and quantity, so we can ignore it when we try to build the real table. Next, I will illustrate detailed version of data normalization using pandas. After the first step, we need to load the whole data and take it as the database, as the base data frame df. And then we need to slice the columns we need from df and form the new entity, for example, customer, and then remove duplicates according to the key of customer, and then assign customer ID to customer. In other words, we need to add a column named customer ID to customer entity. Next, we join customer with city and replace city name with city ID. Finally, export the data. Here, we can see that in order to replace the city name with city ID, we need to join customer with city. The result is showing below. So basically, after merging step, we need to choose the attribute that we need and form a new table, and then store the new table to CSV file, which is more convenient to be loaded to Redshift database. Okay, let's move to the next section.
I'm Yue Zhang, so let me introduce the part of ETL process. Let us briefly introduce the process we made during this part. Xinghao has created the AWS account, launched an EC2 micro instance, and created the S3 bucket. Firstly, we upload the Instacart data into S3 using AWS interface. We created the MariaDB database as our MySQL database to manage the data we have. Our second step is to export the data from S3 to MySQL. This is the main part we go through in the ETL process. This requires us to design the structure of the database and the tables. We have introduced in our first assignment the design of Instacart database, and we will also introduce the design of ABC retail database later in next part. And last step in ETL process is to export data from S3 to Redshift. This will be introduced by Sun Zhang. Uploading to S3 is simple. We follow the professor's instruction according to PowerPoint, and the main part in ETL process is to export data from S3 to MySQL. The data we have are CSV files. We choose Python as our language to operate the process. Our repositories are PyMySQL, CSV, CodeCS, OS, Bottle3, SQL Alchemy, Pandas. We have tried three approaches to export data into database. Firstly, we are trying to understand and practice exporting data from local to database. And the steps are downloading files from S3 into server system. We use AWS S3 copy command to perform recursive downloads of multiple files in a single folder level command. The AWS CLI will run these transfers in parallel for increased performance. The red text is the command. And the second step is to configure the database connection parameter like host, port, user, and password in database. Third step is to use CSV to read the files line to line. And next, we will init a cursor to execute the SQL script, and then commit, and finally close the cursor and connection. But when we use this approach, we have met a problem that when we use CSV to read files, it will ignore the double quotation marks. But in the product table, product names are sometimes different just because of double quotation marks, and we can see that below. And we can use code char parameter in CSV reader to solve this problem. We just set code char parameter like this. And secondly, after practicing from local files, we begin exporting data from S3 bucket using CSV. We also tried two approaches to export data. The first approach is to read file in S3 using bottle3, put the object response, the byte stream, into a list called lines. We also used CSV to read the list and execute the SQL script using cursor. The detailed steps are firstly use the bottle3 to get the object in S3 bucket and then get the response, and then read the response into lines. Secondly, we configure the database connection parameter like we said before, host, port, and etc. Thirdly is to use the CSV to read lines, and we init a cursor to execute the SQL script and commit and close the cursor and connection. In this approach, we also encounter some problems like the CSV file of order and product order is too large. When we read the file, it will cause memory error. And we have figured out some solutions like divide the files into a set of smaller files and then read it. And second solution is to use the third approach and directly read the byte stream. So the third approach will be used by pandas and SQL Alchemy. We use bottle3 to export data from S3 bucket and use pandas to get the byte stream, combine SQL Alchemy and PyMySQL to create an engine to insert the data into database. The first step is to use bottle3 to get the object in S3 bucket, and then we use pandas to read the object's body, which is a byte stream. Secondly, we create the engine using SQL Alchemy. This is the command listed in the screen, and the third step is to use the engine to insert the data to circle, and we input the engine and the table names and some parameters. We set the chunk size is equal to 1,000 so that it will not encounter the big file problem.
Hi everyone, I will introduce the part of using Redshift and import data from S3 to our Redshift database cluster. This is the steps that I followed to create my cluster. Let's begin with step 1. First, we need to create a new role for Redshift to access data from S3. Here, we select IAM, and we select rules. We create a new role here. We select Redshift because we will use that in Redshift, and then we select Redshift customizable. And here we search S3. We select Amazon S3 read-only access. Then you name the role here. We will use this role later in the cluster creation. Then we go to EC2 management console. We select security group here. We create a new group for Redshift. In here, we add a new inbound rule for Redshift. Then we select this IP address. This is the IP address of our EC2 instance. We only want this instance that runs the backend of the website to access to Redshift. Then in Redshift, we can create our cluster. Here we can name our cluster and name the database, the username, and the user password. In here, we add our IAM role here. Then in the network, we choose the security group we created before here, and then we can create our cluster. So this is the cluster that are running the database now, and we can edit the we can log into the Redshift database here. So here Redshift is running on PostgreSQL, so you can use MySQL language on this editor and run it. First, we should create the schema, and we run this line. Then we create the table here. Then after we have the table, we can copy the data from S3 to this table. So in here, this is the IAM role ID. We can find it from here. So this is the role that I use in Redshift, and we can copy the role ARN here and paste it here. And this is the S3 path of your CSV file. You want to copy this file data to this table, and since it's a CSV file, the data is separated by comma. So we put comma as the delimiter here, and we run these lines, and finally we can select from the IO table, so we can see if the data is successfully imported. As we can see here, the data is imported successfully. So we will finish the step 4, and for the next step, you need to install the Redshift ODBC driver to your EC2 instance, and I followed the steps in this article. And after you repeat every step from this article, your EC2 instance could allow you to connect to Redshift with ODBC. So next step we install PyODBC and use ODBC to connect to our Redshift cluster. And that's it.
Next, I'll explain how to process the query and get the result after we connect it to the database management system. When user input the query and click the submit button, we can get a query from the web end, and then we want to check if the connection exists. If it exists, there's no need to build the connection again. That can save us a lot of time and improve the efficiency a lot. If it not exist, we connect to the database and get the cursor of the connection. And then we want to execute the query and try to catch the error or exception. If there is no such exception captured, we can fetch the query result from the cursor. Here we limit the fetch size to 1000 records because we want to make sure our web server is robust, even if the query result is hard to show at one time. Finally, we render the result using the Django tables tool and pass the table to the web end.
In this part, I will introduce a web application, mainly its design and layout. We use HTML5 to realize a web page. Besides, CSS and Bootstrap are used to make the layout more friendly. First, consider there are two databases, Instacart and ABC Retail. If we choose Instacart, it lead link me to the Instacart database. So we can see there will be several links, and it's a good choice to design a navigation bar to accommodate all links, which makes user interaction more friendly. The tools we use is this. Now, let me show the navigation bar. If we click the home, we'll go to this page, which shows the relational schemas of Instacart and ABC Retail. If we click the Instacart or ABC Retail, we will go to this page. Then, let's see the input error. It contains three parts. The first one is the drop-down list, which is used for Instacart database. We can realize it using this. In this part, we can choose one database management system, RDS or Redshift. The second one is a text error. We can realize it using this. This part is used to type in the circle instructions. The final part is a submit button, which is used for submitting the selected database management system and circle instruction. All these three parts need to be placed in the module form. Next, I will introduce the result error. First, we need to choose the database. Then, database management system. And type in the circle instruction. And submit. In the result error, we can see the search results and the elapsed time. We show 25 results in every page. Besides, if we click the attribute name, it will sort the result. Finally, if we type in a run circle instruction, you will see the error information. Last but not least, I will show that we have exported data to RDS and Redshift successfully. I use a circle instruction, table by table. If the result is equal to a number of rows in each table, then it means success. Now I will show that. That's all about our web application. Thank you.